Hello everyone and welcome back to Hetero Learning. Today we will be going through a new Crit B problem. So Crit B is pattern investigation. And today the problem is going to be about the theme of steel cables. Here's some review on what a Crit B is about. So these are the general steps that you will have to follow in any pattern investigation. First, they gave you a set of data. So you want to generate more data. And you generate more data by using what they give you. After that, you organize your data into a table. You use that data, that organized data, to formulate a rule. You verify that rule to make sure it's correct, and then you justify it and say the mathematical side of why it works. So let's start. So our problem today is investigating size. That's what they call the type of steel cables. And versus the number of strands. This pattern investigation is unlike most others because the only piece of data they give you is size 5. Usually they would give you more than one, but here they only gave you one. So it involves a little bit of creativity, and what that also means is that there isn't a fixed correct answer. However, for today's purposes, we will go with one of the more common ways of solving this. Here we have a size 5 cable, and you might notice that it looks somewhat like a honeycomb, except with circles. And the number of strands is essentially how many small circles there are inside the shape. In here, you can count it is 61 strands. And with this shape, as I talked about just now, there are multiple ways to interpret it, as shown on the screen here. So let's start by generating more data. So here, how do you see the pattern growing? Well, here's our first shape that is provided. Let's generate more. So essentially how I think about it is there is another layer outside each layer. So when the size increases by 1, an additional layer is added to the previous shape. So size 6, you can see it's much bigger than size 5, and size 7 is much bigger than size 6, and the number of strands in each shape is listed and written on the screen. Next, we need to organize this data in a way that makes it easy to work with. So here I have made a table of what we have just came up with the size 5, 6, 7. Those are the 3 shapes that we already know and their corresponding number of strands. At the bottom here is the rule that we will soon find out how I got here. This is just to show you, and we're going to explain it right now. So now let's formulate our rule. We are going to use the organized data to generate a rule that fits our pattern. Right, so this should be in the form of an equation. So right now, this is what we have. And as I talked about in the first few slides, there are a lot of ways to interpret this pattern. But I drew this one in a way that I thought would make it easiest for you guys to understand. If you can observe, what we have here is a honeycomb shape with different layers, and each layer is drawn with a different color. So let's look at each layer. Well, each layer is essentially made up of 6 sides, as it's a hexagon. Each side is represented with an arrow, and the length of the arrow, or the number of circles that each arrow encompasses, is always the same for each arrow with the same color. And that number is always increasing by 1 for each layer as we go out. Each side of the third layer has 1 more circle in each side compared to the second layer. Right? So that is how we can interpret this pattern. And on the screen here, I have just simply written out one way for you to interpret this pattern and for you to write it out. And it's just easier to express it this way. and then be able to calculate how many circles there are inside each shape. So that is what we have right here. And we notice that the structure of each equation is actually very similar. So that tells us that we may be able to write this out as a general equation. And that is what we are going to do now. We realize that there is always one circle in the middle of every shape. And that circle is a singular circle. So that can just be represented with the number 1 all the time. And as we talked about, there are a different number of layers for each different size. But the number of sides per layer always stays the same, and that is 6. So we have to multiply everything else by 6. What is that everything else? Well, as I said, the number of circles in each side increases by 1 as the layer goes out. So it starts at 1 and then plus 2, plus 3, plus 4, all the way up to plus x minus 1. You can see this from the diagram. For example, the most outer layer in size 6 for each side has 5 circles. And 5 is 1 less than 6, which is why it's x minus 1. Right, so we can write it like this. We can split the 6 into 3 and 3. So right now I have 1 plus 3 times all of that, and then I'm going to add the same thing, except I am going to reverse everything and write x minus 1 first, and 1 as the final number. What this can do, we'll see in a minute, is it can help us pair up the numbers and be able to see a pattern. And so as we can see, the first pair is 1 plus x minus 1, and that adds up to x. The second pair would be 2 plus x minus 2, and that pairs up to be x again. So they all pair up to be x. But how many pairs are there? Well, 1 plus 2 plus 3, so we add them up all the way to x minus 1. Well, you can easily see that there would be x minus 1 numbers. But be careful here, we have duplicated this. So there are x minus 1 pairs of x, and we have to multiply that by 3. 3 times x minus 1 plus 1. That would be our pattern. And so our answer would be that in general, we can express y as 3 times x squared minus 3x plus 1. So here we have formulated our rule. Now we are going to move on to verifying it. And we do that by getting a different data point and drawing out the shape for that point and then seeing if that also matches the pattern that we have described. So here's our proposed rule. And we're going to take size 8 because that is a shape that we haven't worked with yet. And we're going to look at, well, according to the rule, when x is 8, what should y be? Well, the rule tells us that y should be 169. So we have to check if it's actually 169. How can we do that? Well, we can do it by counting, right? So in reality, there are 169 strands. And this proves that our rule is correct. Now, we can move on to the justification. And the justification really is about explaining why and how your rule works. And there isn't a fixed way to do this. Actually, although this is supposed to be the hardest part, here you can make it the easiest part. And why I say that is because you can simply write, we have already justified our rule while formulating the rule. Because when you think about it, when we were formulating our rule, we used a mathematical way of finding out how to write our rule. We did the general rule of how we can add up the numbers. We paired them up. We thought about how many pairs and what the pairs sum up to be. And so all of this is technically justification because you are thinking about why this rule works and how we got here. So really, if you had the ability to come up with that beforehand, the justification is really just saying we've already done that. But if not, you did something else during the formulating part, then you of course can bring that out and put it in the justification. So that is the end of our investigation for today. Hope you guys enjoyed this crit B investigation and hope it can help you do better on your next test, on your next, practice, whatever it might be. And good luck on that. Please like and subscribe to this video and see you guys next time.